Dear students, in this class we are going to see the concept of drift and diffusion currents. It is a very important concept in semiconductors, and already we have seen the definitions of conductivity and mobility. Those expressions are also very much essential to understand this concept. So first of all, let me say the differences between the drift and diffusion currents. So what is drift current? Drift current means it is due to potential gradient. Let us take a semiconductor here. In semiconductor you are having two types of carriers, holes and electrons. Holes and electrons like this. Then if you are applying some potential outside from this, let the potential is nothing but V like this. Then whatever the current that is flowing through this semiconductor is called as drift current. Drift current means it is due to externally applied voltage. And due to this potential gradient, whatever the current that is existing in the semiconductor is called as drift current. This drift current may be due to holes as well as due to electrons also. And now, already in the previous class I told you the conductivity definition. What is conductivity? Conductivity is nothing but sigma is equal to N Q mu. And the current density J is equal to sigma into Xi. These are the expressions I already told you. Sigma is nothing but the conductivity here like this. Therefore, if you write this expression for the holes as well as for electrons, because in semiconductor there are two types of carriers, holes as well as electrons. And due to holes I can write down Jp is equal to some sigma p into Xi. That means conductivity due to holes. How to write the expression for the conductivity due to the holes? Sigma p is equal to, in the place of n you have to write down p into q into mu p. It is a generalized expression. So I can write down Jp is equal to sigma p due to holes means the concentration will be small p and into q and this is into mu p into Xi. This is nothing but the current density due to holes. And this current is due to the externally applied voltage. That's why it is a drift current. There are two types of drift currents here, due to holes as well as due to electrons. So fundamentally what is the drift current? Drift current means it is a current which is flowing because of externally applied voltage. And similarly, can I write for the electrons? Yeah, for electrons I can write down Jn is equal to n into q into, this is mu n, mobility of electrons into Xi. This is nothing but your electron drift current like this. This concept is actually discussed very clearly in the last class. So finally remember my dear friends, your drift current is the current due to externally applied voltage, means potential gradient. But in this class, the most important concept of the semiconductors we are going to discuss, that is nothing but the diffusion current. So what do you mean by the diffusion current and what exactly this diffusion concept? So listen carefully. Let us take a semiconductor and the semiconductor is placed in the direction of x like this, and inside the semiconductor you can expect the presence of the holes and electrons, and holes will be in random. So let us say that this is at x is equal to 0 and these are nothing but the number of holes, you can say like this, these are nothing but the holes and these are nothing but the holes variation like this, this is. Now that means holes are varying in the direction of x like this. Let us take an imaginary surface like this, and these are nothing but the whole concentration, let it be the P. So this graph is telling the variation of holes with respect to distance x like this. So now if you are taking like this and if you take an imaginary line n and n dash like this, let it be the imaginary line. Observe the concentration of the holes. Immediately you can say the concentration is not uniform. It is always having different values this side and different value that side. That means the concentration of the holes is not equal in both directions. So whenever you are taking this line, suddenly we can observe more number of holes are for this side and less number of holes are this side. Then at that moment, also the current flows from higher concentration to the lower concentration. A current which is flowing due to the concentration gradient is called as diffusion current. So, what is the meaning of diffusion current? Diffusion current is due to concentration gradient. Concentration gradient. That means due to the difference of concentrations, the current is flowing concentration gradient. Gradient means change. But whereas your drift current is due to potential gradient. Listen carefully, because the most important concept which is required to understand the concept of your diodes and transistors and everything. So, if you take this whole concentration, because of the concentration difference, some current is flowing from higher concentration to the lower concentration. So, here as it is a statistical phenomena, the experimental fact is telling whatever the current that is existing here, that is nothing but current due to holes, Jp, current density due to holes is directly proportional to, you can say, dP by dx. What does it mean? dP by dx means rate of change of holes with distance x. If the rate of change of holes with distance changes like this, then the current is flowing. So, finally, I can remove this proportionality Jp is equal to minus q into dP into dP by dx. dP by dx. What is dP here? dP means diffusion constant for holes. What is the dP by dx? Rate of change of holes with distance x. But I have written here a negative symbol here, negative sign here. Why? Why it is negative? Because holes are moving from this to this. It is a current direction. But you are putting a negative here. The reason is dP by dx is nothing but change of holes with distance x. Whenever you are traveling in the x direction, change of holes is negative because they are going on decreasing. So, dP value is negative. Negative of negative is positive. That's why you have to put a minus sign here. Because holes are moving from this to this, so current direction is nothing but the whole direction. To make it positive, I am putting a negative sign here. dP is always negative. Negative of negative is positive. And this is nothing but the diffusion current. This is Jp is equal to minus q into dP by dx. And diffusion current is due to concentration gradient. But whereas your drift current is due to potential gradient. I would like to give a small example to understand this. Suppose, for example, if we take our class, because of the lecturer motivation, because of our lectures, whatever you are learning, whatever the current that is flowing in each and every student, because of our lectures, that is called drift current. Drift current means very simple, my dear friends. It is the current due to externally applied voltage. Somebody is coming here, teaching to you, and you are learning. That is called drift current. But one thing is, what is diffusion current? It is concentration gradient. And nobody is telling this concept. Concentration means because of the student's interest, whatever they are learning without any motivation, because of this necessity and because of their involvement, whatever the current that is flowing already inside the students is nothing but your diffusion current. If you want to get an excellent position in your life, diffusion current must be there in every student. Drift current is only for motivation. If the drift current is absent, if the lecturer is absent, it will be zero. But diffusion always has to take place. It is very simple. I would like to tell you one more example, my dear friends. Suppose, for example, if you want to take a house at the city center. At the city center, everybody knows it is so costly. We are not able to afford the price. So generally what we do, we would like to do our journey to outskirts of the city. Whenever you are going from higher density to lower density, definitely the cost will be very less and you are going to get a house at your price. But nobody is telling to you. Automatically you are understanding that whenever you are going to outskirts of the city, you are going to get an excellent house. That means you are migrating from higher concentration to lower concentration. Nobody is taking care of this. That is called diffusion current. Whatever we are actually learning from our experience, it is called diffusion current. In semiconductors also, we are not at all giving any type of supply to this, any type of potential to this, but the current is existing from higher concentration to lower concentration. That is called as diffusion current. This diffusion current is Jp is equal to minus Q into dp by dx. But whereas, what is the drift current here? The same example I am telling you. If somebody is there and he occupied some place in the city, and by compulsion the collector and police people will come there, they are going to ask them to vacate, and then also the current is existing. That current is means by compulsion they are actually asked them to vacate. That current is called as drift current. Drift means due to externally applied forces. Diffusion means the internal phenomena, that is nothing but your concentration gradient. So remember, my dear friends, there are two types of currents in semiconductors. One is the drift current, other one is the diffusion current. So this is the diffusion current due to holes. The similar analysis I can say. What is the diffusion current due to electrons? Very simple. Replace P with N, you are going to get this. Therefore, I can write down Jn is equal to, instead of minus, you should be plus Q into dn by dx. This is nothing but the current density due to electrons. So, I have written the expression for diffusion currents as well as the drift currents now. So, if you want to write down the total current in a semiconductor, it is a combination of your drift and diffusion. So, I can write here total current due to holes. Total current due to holes. So, what are the currents you can expect? There are two currents, which one is nothing but the drift current and other one is nothing but the diffusion current. So, what is the current due to? Drift current due to holes. Drift current due to holes is equal to Jp is equal to, I can say, Pq mu P into Xi. This is the current. This is Jp. This is called drift current. This is drift. What is the diffusion current here? Just now I write down. This is Jp is equal to minus Q into dp by dx. This is nothing but the diffusion current, I can say. So, these two currents combined, you are going to get the total current here. So, Jp due to drift, due to this thing. So, Jp total due to holes, what is the total current? I can say total current is equal to, you can say that P Q mu P into Xi minus Q into dp by dx. Friends, no need to remember, just understand the concept. Then definitely you are going to get the concept very well. All these concepts are very much essential to do the problems in your competitive examinations like your GATE and IES. Understand it clearly so that it will be stored in your permanent memory. If you by heart, you are not going to get the concept. Understand the physical examples so that you can understand it very clearly. Then, what is the Jn? Automatically I write down Jn means current density, total current density is equal to, I can say that this is N Q mu n into Xi plus Q into dn by dx. These are nothing but the total current expressions. One is due to holes and one is due to electrons. So, this is the way of writing the expressions for the total currents in a semiconductor, that is nothing but the combination of drift and diffusion currents. So, finally, I can say in a semiconductor, there are two types of currents. One is nothing but the drift current, other one is the diffusion current. Drift current is due to potential gradient, diffusion is due to concentration gradient. And drift current expressions and diffusion current expressions already given here. If you sum up these two expressions, you are going to get the total currents here. But remember friends, here one more concept is excellent concept. Already we have seen the mobility concept. What do you mean by the mobility? I told in the last class, it is an ability to move. Mobility means ability to move. Mobility is more for electrons and less for holes. Suppose if you take two persons, one is very lean, one is very heavy. If you apply the same force for them, a lean person will be displaced for a long distance, whereas a heaviest person will be there only because the mobility is less. So mobility is less for holes, mobility is more for electrons. This mobility concept and your diffusion concept dP is actually related by an excellent equation which is nothing but the Einstein's relation. But Einstein's relation, before going for that Einstein's relation, let me derive the unit of the diffusion constant also. Because in our engineering, units are very much important. Don't by heart the units. Try to understand the way of getting the units from these expressions. Okay, now let us do a small derivation for getting the unit of your diffusion constant. Just now we have seen the mathematical equation of this diffusion constant. Jp is equal to minus q dp by dx. And coming for the units, what is the unit of current density? Ampere per meter square is equal to, charge will be minus coulomb, and dP means diffusion constant. Would like to identify the unit of this. Change in holes, and I already told you hole concentration means number of holes per meter cube. So the what is the unit of dP? 1 by meter cube, 1 by meter cube into dx means distance, it is in meters, that means m to the power of 4. And ampere per meter square is equal to minus, what is coulombs? I is equal to q by t, you know this. Charge is, current is nothing but charge by time. Coulombs means ampere into second because q is equal to I into t. So I can write down here ampere into second dP by 1 by m to the power of 4. And this will be cancelled, and ampere will be cancelled. Therefore, the unit of dP is how much it will be? Meter square per second. Meter square per second. So this is the way of obtaining the unit of your diffusion constant. So once you are getting this diffusion constant unit, then I would like to tell you the relation between the statistical parameters, nothing but the mobility and as well as your diffusion constant. So now I would like to tell you the Einstein's relationship. So Einstein has given the relationship between your diffusion constant as well as your mobility. After having so many number of experiments, he found that dP by mu p is equal to dN by mu n is equal to k bar T by Q divided is equal to T by 11,600. dP means diffusion constant for the holes, mobility for the holes, mu p. dN means diffusion constant for electrons, mobility for the electrons is equal to k bar into T by Q. What is k bar? Boltzmann's constants. Boltzmann's constants in joules per degree, joules per Kelvin. So you know k bar is actually here, you are having a relation k bar with some k also will be there. What is that k? 1.602 into 10 to the power of minus 19 into k. This is the relation we are having, k bar and k. K bar unit is, you can say, joules per degree Kelvin. It is a mechanical unit, joules per degree Kelvin. But whereas your k is nothing but electron volts per degree Kelvin. I already told you in the last classes, we are using the energy unit electron volt for finding the energy gap between the valency band and conduction band. If you remember exactly, in the first class itself I told you, the materials are classified on the basis of the energy gap that is existing between the valency band and conduction band. That energy is measured in electron volts. So this is the basic equation required to understand this. So what is T? T means temperature. Generally, we are going to take a room temperature. If the temperature is not given, that room temperature is nothing but 27 degrees centigrade. But this T should be expressed in terms of Kelvin. How to get this T? Just add 273 degrees centigrade for your 273 K. Then you are going to get your 300 degrees Kelvin. This is nothing but 300 degrees Kelvin. Very simple, friends. You have to substitute the temperature in the Kelvin square. If the temperature is given in the degree centigrade, simply add 273 for getting it. It is a very simple fundamental what you have learned during your school days. So once you know this, then happily you can have a relation between the diffusion constant and the mobility. That's why remember, dP by mu p is equal to dN by mu n is equal to K bar T by Q is equal to T by 11,600, and this is fundamentally equal to Vt. Then you can ask me, what is Vt? This Vt is nothing but, this is equal to Vt. This Vt is nothing but volt equivalent of temperature. Volt equivalent of temperature. Volt equivalent of temperature. So with respect to temperature, how much voltage is producing? That is called Vt. And remember, friends, for so many problems in your examinations, this Vt will be 26 millivolts at room temperature. Just now I told you, at room temperature means at 27 degrees centigrade. If you convert into Kelvin, it is 300 degrees Kelvin. So at 300 degrees Kelvin, if you calculate this T by 11,600, that will be equal to, your Vt is equal to 26 millivolts. This is the most important data required to do your problems in your semiconductors, even in diodes also. So that's why really you can appreciate the efforts made by the Einstein to give the relation between the statistical phenomena, diffusion constant and the mobility. Because diffusion constant and mobility, they are indirectly telling about the concept of your drift and diffusion currents also. So diffusion current is nothing but a current which is existing due to the concentration gradient. What do you mean by gradient? Gradient means change from one place to the other place. It is a gradient. For example, if you take a rod, if you are putting this rod on the stove like this, it is a steel rod, you are going to get a temperature here. Because gradient of temperature is existing across this rod. Exactly, concentration gradient. Wherever there is a concentration gradient, the current is flowing, that current is called diffusion current. And if the voltage is applied from externally, that means if you apply from outside, then also the current is existing, that current is called as drift current. So in future, whenever we discuss about a diode initially it will be having a diffusion current whenever the voltage is not applied. Whenever the voltage is applied, it will be having two types of current, diffusion as well as the drift. That's why the current in a diode will be the sum of diffusion current as well as drift current. I think you understood this. So students should have a diffusion current. Whatever the currents that are existing, whatever the fire they are having, because of their own individuality is called as, because nothing but diffusion current. If you want to highlight in the peak, diffusion current has to dominate the drift current. Drift current means because of somebody you are learning, but you should be the self-learners. And whatever the knowledge you are getting because of the self-learning is called as diffusion current. Whatever you are getting because of the presence of others, it is called a drifting. The result of each and every person is nothing but the sum of the two contributions, drift as well as diffusion. Understand it very clearly. It is almost all the natural concepts. If you understand like this, nothing is there. So every concept is the most important and beautiful concept in your electronics. Try to understand this. I hope you understood your differences between drift and diffusion currents. One is due to, drift is due to potential gradient and diffusion is due to concentration gradient. Okay? Thank you very much.